we have to evaluate this double integral. As you can see, as an integrand function e raised to the power minus half x square plus y square is given. So if we change the order of integration, then derivative of either x square or y square is not present in integrand function. So there is no better choice to change order of integration. So how we will proceed this problem? Whenever x square plus y square is involved in the integrand function, always try to change in polar coordinate system. According to this, x square plus y square you can replace by r square, and new limits of r and theta we will find using the region of integration. As you can see, limits of x are minus infinity to x equal to y, and limit of y are minus infinity to plus infinity. Using these two limits, try to draw the region of integration. Suppose this is xy coordinate system, and this is the line y equal to x, and x is varying from minus infinity to this line. So we have, this is the region of integration, means you can see left part of the line y equal to x. In this you can see theta is varying from pi by 4 to pi by 4 plus pi, means 5 pi by 4. So theta is varying from pi by 4 to 5 pi by 4, and r is varying from 0 to infinity. Use these new limits of r and theta, try to find this problem. So 1 upon 2 pi, now I can write 0 to infinity and pi by 4 to 5 pi by 4, and integrated function was 1 upon 2 r square and Jacobian r dr d theta. Now take derivative first with respect to theta, because of we can treat this as this integrand function as a constant. So integration with respect to theta will be 5 pi by 4 minus pi by 4, and constant function e raised to the power minus half r square is same as, and limit 0 to infinity outside 1 upon 2 pi dr r dr. This pi will cancel out this one. So finally we have 1 upon 2 limits running from 0 to infinity e raised to the power minus half r square r dr. Now let minus 1 upon 2 r square as t. So using this we have minus r dr equals to dt, means integration of this one will be minus of half, and e raised to the power minus 1 upon 2 r square, limits are 0 to infinity. You know very well graph of the e raised to the power minus x. This is the graph of e raised to the power minus x. As x is tending to infinity, this graph is going to 0, and when x is tending to 0, graph is reaching 1. So minus half is half was outside. So finally we have 1 upon 2 is final answer. According to this, option D will be correct option.